the next talk is from Fabien Holin, who's an expert in LoRaWAN. He's been with Semtech for a while already, and before that he was already working with LoRaWAN. He's a principal engineer in software development, specialized in LoRaWAN applications, geolocation applications. Is basically the architect of LoRa Basics Modem stack that he's going to talk to you about today. So, Fabien.
Thank you, Olivier. Very, very happy to be here with a community of developers in the city of startup. So it's really a great chance for me, and I would like to thank the LoRa Alliance to give me this opportunity to talk with you about my favorite topic, let's say. So just the presentation just before give us a global overview of end-to-end solution LoRaWAN. So in this presentation, I will just focus on one part, but just of the end device part, just the code running inside this end device. But I have a question, at least for you. Who already know LoRa Basics Modem? Semtech can't vote. It's too easy. Okay, so maybe just one people in the room. Okay, and who already use the LoRa Mac node? Okay, that's fine. So maybe I try to explain the slide without the slide. So, I would like to talk with you about the LoRa Basics Modem, which is a new stack developed at Semtech. And it's always difficult to explain in few words a work of 5 years, let's say. So what I suggest is just to make a travel together, a 1 hour's travel together. And the travel is starting from, so you have the map here, but the travel is starting from San Francisco. And just, I will try to give you a global overview of what is LoRa Basics Modem. That means what it is, why we develop it, what is the feature embedded inside LoRa Basics Modem, and so on. After, we will jump to New York in this virtual travel. So in bicycle, we will join New York. We take the bicycle because I already burned all my CO2 this week. But we will have a long stage in New York, a very long presentation because it will be a live presentation, so a live demo. So very risky for me, but could be very funny for you if I miss. But okay, so I will try to develop in real time a very basic LoRaWAN. Okay, a very basic LoRaWAN example. After, we will jump to, let's say, Europe, and to discover the extra feature already embedded in the LoRa Basics Modem, because the LoRa Basics Modem is, as you understand, a new LoRaWAN stack developed by Semtech, but it's not only the stack. It's also stack plus services plus plenty of other things. So I will try to just expose you or to give you a short list of what services is already embedded inside the stack and how it is attached to the LoRa Cloud services, which is another part of the Semtech delivery, which is the cloud part of Semtech. After, and I think now you have understand the idea behind this travel. In fact, this travel is more or less the same thing you have to cover when you develop by yourself a real LoRaWAN product. That means you have a kind of understanding for one thing, try to experiment on a SDK and so on, and after this, you have to probably have to make a POC on your own hardware. That means at the beginning you're starting with a AVK board or something delivered by Semtech or by ST or anyone, but after you have to put it in your hardware platform. So we will see how to port the LoRa Basics Modem in your platform, what is a thing to manage. And let's step off this travel. Let's go to production, because I think it's more or less easy to execute a POC, but it's really much more difficult to switch from this POC to a real mass product. So we are thinking about this since a few years inside Semtech, and we have tried to put plenty of things inside this LBM to help you to succeed from your POC to your production. So I will try to demonstrate some of them, and I'll try to also evocate some of them. So, and at the end we will come back. So sorry, there is no map, but we will come back to San Francisco for a Q&A session. Let's say. So yeah. So this slide, just to try to explain what is the DNA, let's say, what's the philosophy behind LoRa Basics Modem. Why we are developing a new stack at Semtech? Because we, as you know, we already have a stack at Semtech. This is a LoRa Magnet. So what we are developing a new one. So as Olivier said, I work on the LoRaWAN now is a teenager, in fact. LoRaWAN, it's more than 10 years, the LoRaWAN. And I work more or less for 10 years also in the LoRaWAN. And what I'm for sure understand or learn during this 10 years, it's not so simple to develop a full LoRaWAN product, I think. And another thing I will more or less convince also, if we want to succeed, let's say, I think a developer should be able to develop a full efficiency product without read one word of the LoRaWAN specification. So sorry for the technical committee, but I think it's really important for this. So that means, and today, it's okay. So when you want to implement a LoRaWAN product, it seems very easy at the beginning, but there is plenty of ways to fail. Just let me give me 2 examples. At least 2 real examples, unfortunately. So you imagine you take a stack of reference that it is today. You just develop a product on top of it, just transmit periodically a message. So you make a POC, join, and so on. Everything is okay, is working perfectly well. You put plenty of devices on the network, everything is still okay on the public network. And unfortunately, for any reason, this public network drop the services of LoRaWAN. It should arrive sometime. Or you can also imagine another thing. It doubles the price, or it multiplies the price of the communication by 10. So you can't still to use this network. Everything is working in your device, but you can't. If you have not implemented something that allows you to rejoin easily, so you are in the big mess, let's say. So one thing, and it's exactly an example I would like to share with you, because the LoRa Basics Modem, when I say that the LoRa Basics Modem is more than a stack, we are trying to collect all the feedback we have from these different examples, and we try to put it inside the LoRa Basics Modem just to improve the reliability of your end product, in fact. And I think it's very difficult to let all these things at the application level, because how to be able to collect all these things, and I think it's really important to put it inside what we call LoRa Basics Modem, so more than a stack, just to secure your end product. So and when I want to say, in fact, using this LoRa Basics Modem, I think what we want to achieve is really to ease the life of the final of the end developer. And when I say in the life, it means work less, but sleep better also. That means work less because plenty of things is already embedded inside the stack itself, but the reliability is really the key word for LoRa Basics Modem. Every time we are trying to do something, we are trying to do with a mindset of reliability. Reliability because your device can crash, but also reliability because the network server can crash, because your application server can crash. Let's give you another example. Everything is okay. You have deployed full product, and by mistake, your application server delete on your network server the device. Just after you plug again the device, but for a few moments, it just deleted. You lose your keys, you lose your session. The device continues to transmit, but you never seen it because the context is changed. So the only way you have to do this is to have a mechanism inside the device to perform a reset, at least, because you are able to see, okay, I don't receive downlink for a long time, probably I lose the context, so please have a reset. And so this kind of feature is already embedded in LoRa Basics Modem. So sorry for this long introduction, but I think I would like to share with you the mindset behind the LoRa Basics Modem. Oh, map is still different, but okay. So just deep dive inside the architecture of this product. So at the bottom we have very classical, so Semtech radio driver, radio abstraction layer, very simple. So, but I think one of the first key blocks of this stack is what we call radio planner. So what it is a radio planner, and what do you are thinking to this? In fact, radio planner is a kind of scheduler, let's say, a kind of operating system, but really dedicated for the radio. And what is useful for us? Because as you know, and it is the case for most of the previous stack, it's very easy to use this stack with LoRaWAN, but it's very difficult to share the radio between LoRaWAN and another stack we want to use the radio planner. We want to use the radio. That means to interleave LoRaWAN communication and other communication is difficult with the previous stack. And so we are thinking about radio planner to be able, in fact, to have multiple stacks running in parallel. It could be two LoRaWAN stacks, one private stack, one public stack. It could be also another protocol or a proper legacy protocol and a LoRaWAN protocol. But it could be also a relay. So the next, the relay is now, I think it's now accepted by the published by the technical community. So the relay is coming soon, and it will be very easy to develop thanks to the radio planner. It will be also the case for the device-to-device we will demonstrate this afternoon by Dev. So device-to-device is a kind of new protocol, just very close to a LoRaWAN stack. But for us also, it will allow us also to have, you see, the LoRaWAN class E is completely independent for class B and class C. So, for example, as you mentioned this morning, just after, class C is just, what it is class C? It's just, in fact, I want to use the radio to listen one data rate to one frequency every time the radio is available. So, but class E is just transmission, wait for 5 seconds, let's say, RX1, RX2. So in our implementation, the class C is just something we ask full access to the radio every time, but with a low priority compared to a class E. So like this, you can see that the implementation of the class C is maybe, I don't know, it's less than 1 KB in the LoRa Basics Modem. And you can interleave easily between just after transmission, just after RX1. If you put it inside the class C without the radio planner, it's still fast, a big mess due to the fact you have to manage a state machine with after transmission and so on and so on. Exactly the same thing for class B. So go to this layer also. So what you see is everything is independent. And it's also very important for us for what I mentioned, reliability, because when you develop a class C, if you develop something in the class C, you are sure you do not broken anything in the class B in the class C, because there is nothing, no code of class C or class B inside the class C. So class C is just a very simple state machine. We perform TX1, TX, RX1, RX2, that's all. Nothing related to class B, to class C, nothing, and it's exactly the same thing for LBT, for example. If you have listen before talk, it's not a represented it, but LBT, what it is just, I want to access to the radio to sniff if there is something before to start a class E, in fact. So LBT is not embedded inside the class E in our stack. It's just a new block, not represented, but here. Same thing for duty cycle. In fact, duty cycle, it's not really in class E, class B, class C. It's a kind of services. So on top of this, just to ask to the radio planner, how long do you, because the radio planner also perform a kind of statistic to say there is this stack consumed as an amount of time for transmission, an amount of time for reception, and so on. So this is another thing not represented here is the management of the region itself. So in the LoRa Basics Modem, there is an abstraction layer for each region, but we are able to build and to build all the region, but with a small impact of the RAM itself. So it's new compared to the previous stack. In the previous stack, if you should embed the full region, but there is a big impact of the RAM. In this stack, it's just so if you embedded one region or 10 regions, so the impact is exactly the same. So all of this, it's more or less what we call a LoRaWAN stack today. So it's the same thing, it's more or less the same diagram except for the radio planner for LoRa Mac node or for another stack. Now, in LoRa Basics Modem, we have a new layer on top of this. And for many reasons, let's say. First, in this upper layer, we have the LoRaWAN package, just to support the multicast package, to support the clock sync package, and so on. So in the LoRa Basics Modem, these packages are already available and embedded. But we have also what we call device management. So device management is just a collection of data and transmit to the LoRa cloud developed by Semtech also. But it should be uplink, but as I mentioned just before, it should be downlink also. It should be downlink to perform rejoin, to save it, to perform reset, or also to perform just a request of some parameter of the device. And at the beginning, it should be not so relevant, this kind of device management, but it can really serve you of plenty of things. In fact, we developed it thinking of all these use cases we sometimes fail for just because you forgot to something in your application level, in fact. And we have also modem services. So modem services is more higher level, such as fragmentation, such as large file upload, large file download. We have a question this morning of what is when you lose the network for few time, how do you be able to rebuild your full data? We have a stream services. We really answer to this question. So because even you are the application level, and you have to thinking all of this, and sometimes it's difficult, and maybe it requires you to really know all the detail of LoRaWAN, or you can take this LoRa Basics Modem and plenty of things is already embedded, let's say. And also we have geolocalization services, but it's really dedicated for a specific radio of Semtech. And again, on top of this, we have what we call a supervisor. So what is useful a supervisor? Because when you just transmit one packet with a periodic packet, it's easy. But but in real life, probably you have transmit one packet, you want also to perform large file upload for data collection or for every month transmission packet and so on. And so you have concurrent access to one stack, for example. So you want to transmit. So this is already also embedded in the stack itself. So, and we will see just later in the example. You can, for example, say, transmit this, push my large file upload, and I don't know, perform also device management. without knowing the time before. Just let the supervisor just manage this. And of course, we have a modem API. So maybe I will be quicker on this. The feature, so it's what it is the LoRaWAN feature is just okay. The last one, the last published one, let's say. So 1.0.4, Class C, Class B, Class C, regional. LRFHSS is also supported in LoRa Basic Modem. Management of multicast session, LBT, duty cycle. Okay, each time so maybe I should start by this, but LoRa Basic Modem is a source code, free, available without licenses. But each time we deliver a LoRa Basic Modem, we pass also the certification with a DECRA certification. So, and we certify all the region. Okay, some small trick, but I can't make the list. But so as you mentioned before, in the LoRaWAN, we are still the big mess of RX1, RX2. Because RX1, RX2 is just, let's say, 5 seconds after the transmission. But 5 seconds, if you have a good clock or a bad clock in your MCU, 5 seconds, it's not always 5 seconds. So we have to, and you can also have delay on this board due to the fact that I don't know, you switch on a T6 or I don't know. So, and it's always difficult to really compensate or to estimate first and to compensate also this delay. So what we are onboarded, it's an automatic delay compensation on the stack itself. So that means you start, you have not the good clock, the right clock, you are not too far, but you can't open at the right time. So you will lose for sure the first packet if there is one, but it will automatically go to the right value after few transmission. Okay, another thing also is the data rate. In the previous stack, let's say, you can choose between two data rates. Let's say more or less the data rate managed by the network, as it is recommended by the LoRa Alliance, until you are static. As soon as you are mobile, it will be difficult. So on the previous stack, you can choose just one data rate if you don't want to use the network data rate. But in the LoRa Basic Modem, we have changed completely the mindset. You never, except in one case, but we never use one data rate. We use a distribution of data rates. That means when you want to perform transmission, sometimes it is at, let's take a data rate 1 or 2 or 3, and we also manage a number of retransmission. And we have different profiles to this. That means if your device has really very low power constraint, so we will use high data rate and a big number of retransmission, or not too big, but everything is always embedded in the stack itself. So we will try to optimize also the parameter of the network, even if you are not in network control. Of course, you can choose custom data rate, and in this case, you can choose every data rate, so just one data rate. So the code structure, okay, so the state machine is very simple for Class C. So the implementation of this state machine is very simple. And I think it's really important, again, for the reliability. So there is no interleaf test machine and so on. It's very, very basic, the implementation. So as I said, Class C, Class B, Class C are independent. LBT and duty cycle are fully independent also. Region also. Okay, so another thing very interesting, I think, is the fail-safe and watchdog. So watchdog is embedded by default in the LoRa Basic Modem. That means if something happens, I don't know, if your radio is stuck or something, or if you have a missing point, watchdog is expert. It's the same thing for fail-safe. Fail-safe, what does it mean? It means you try to perform LoRaWAN for 2 minutes, it's very strange. Normally, LoRaWAN is just transmission, RX1, RX2, maybe 2 or 3 or up to 15 retransmission, but that's all. So you can't stay in the LoRaWAN process during 2 minutes. So in this case, it performs a reset also. So as you see, we try to implement plenty of backdoor to avoid to your device to stay stuck, in fact. Okay, nothing is done under interrupt. So because, okay, as you know, it should be very difficult if you take your MCU for too long time, you can't read your sensor and so on. So I think it's very important. It should be implemented or bare metal, or you could also run a RTOS on top of this. Code size, it's more or less the same that the LoRa Mac node. So I can't say it's better. I can't say it's smaller. It's more or less the same, but as you see, there are plenty of other services on top of this. And for the RAM size, it's really better if you have plenty of region. Okay, dedicated. Okay, so just a quick overview of the services because we are seeing more in detail after. We have device management, clock sync package, so FOTA also, large file upload, stream. Stream is more or less to answer to your question of this morning, large file download, and geolocate services. Okay, so the supervisor is, okay, I think I talked already of the supervisor. Same thing for the, oh, no. For the modem API, I think it will be more clear during the live demo. But everything is done under asynchronous event. In fact, but I think it's more clear during the event. But the idea is just to, if you want to build your own application, you can do it just on asynchronous event. That means on reset, perform this. On join, perform this. On a reception after transmission, this. Tunneling, this. So and we will see all the events you can receive with LoRa Basics Modem. Okay, so let's switch to the demo. So the first thing I want to try, it's really to prototype and to be able to join a network from nowhere, from really if you start from nothing, and to join a TTN network in these cases in less than 5 minutes. So maybe I can try to do it. So let's, please. So I use all right, LR11, I can't, yes. I use a platform like this. It is just a LR1110 plus a Nucleo board. So sorry, I have to make my glasses. Okay, so just find the, first thing, find the LoRa Basics Modem code. It is on the GitHub LoRaNet, so it's an open source code. Just take in. Okay, make a demo. And git clone. Very usual for developer until now. Okay, CD, sorry. Okay, open the code here. Okay, this is the LoRa Basics Modem code. And we provide only one example in this LoRa Basics Modem, a very basic one, just perform a join, and when you press the button, you transmit an uplink. So, okay, make a terminal. And make, because you don't want to read the fucking manual. So, make. Oh, thanks. There is an help, a log, to help you to compile. So my target is LR1110 region, all the region by default. So make. Maybe I have a shortcut. Okay. And put the trace. If I do this, for sure it will fail. Why? Because I have at least to put a key. So let's try a key. So DVI, join UI. I don't put the same one. And also I have to change the region. Let's go. So I compile and download the code inside the nuclear board itself. Okay, so now I have to provision my device on TTN. So, sorry, I'm not using the QR code. I'm old school. So just interspecific manually, I will choose. Okay, as you know, in US there is 8 frequency bands. Just choose the first one to not waste your time waiting for join. LoRaWAN specification 1.2.4. Regional plan. This one. Join UI, okay, I don't remember. Free. Level 2. Key 4. And that's all, I think. So even without QR code, it's not so difficult. I hope. So, okay. So now let's start. Maybe I will use this tool. Okay, just. So, okay. So what we see? Transmission, RX1, RX2, on RX2 there is a reception. So that means we are already joined now. And we can check on the dashboard of TTN. You see join, John accept, John request, John accept, it's already joined. So I think it's not too close to the 5 minutes, I think. And again, so what you can see also, it's a first, I asked nothing, but the first message is starting on port 199. It's the port, in fact, dedicated for the LoRa cloud services. So that means with LoRa Basics Modem, even at the beginning, we're just transmitting some information of the device to be able to collect, I don't remember exactly what, but we have the number of reset, a collection of full data. So now, if we just press the button, it should, okay, it should transmit a packet. Press, transmit, reception, and this should be appear in the TTN. So, okay, it's a very, very basic example, but what can I see here? Maybe it's a little bit verbose. For sure it is. Okay, so just, okay, for the US, there is a little bit more difficult frequency plan, let's say. So we have a log with the frequency plan, and we have also a log of which frequency is used and which channel is used. That means here, what you see just, in this case, it's just randomly, but in this case, it's the first one. But it uses the first channel and in this case, the first frequency to try to join. And if we continue, we will jump to the next channel, etc. So this is the first thing I want to demonstrate. Can you go back to the presentation? Okay. So now we try to implement it just to see how it's works, in fact. A very simple but incremental example. First, we will just try to implement a periodic transmission of a temperature, let's say, on a periodic alarm. And after, we will put a second thing just to receive a downlink, to parse the downlink, and just to, in this example, to add an offset of the temperature sensor. We'll go a little bit more deeper. We try to get the clock coming from the network. It should be from the clocking services, but it could be also to a network coming from the network server. Just for, in this example, just to get the temperature at the fixed time. Just an example, so it's a good idea to take the temperature at the fixed time. It's not a good idea to transmit the temperature at the fixed time. Because if all your fleet transmit at the same time, maybe it's not a good idea. But all of this thing also is also embedded inside the LoRa Basic Modem. That means even if you say transmit at this time, except for we add some random time just to avoid that if you just to avoid that all your devices of a fleet collide at the same time. And after this, we try to transmit a large file upload in parallel to the other thing, just to mimic a kind of 1 week set of temperature. I will try also to change the data rate just to see how it works. And we have a final demo also. Don't use your key as I put here, but just to use a key coming from the join server on Semtech. So just have a look on the code to do this. Can you? Yes, thanks. So let's take our time. So it's exactly the same code as before, so just the git clone, but I have had a new main example. So if I add in this code just a prefix to see the different steps I have described just before. So take a look of how an application should look like on top of LoRa Basic Modem. So you have just a basic initialization just after just at the beginning of the code. So I think you can keep more or less like it. It's just to initialize everything. And it's more or less, you have just two things. Just call the run engine. So call the run engine periodically. So the run engine is just execute something in the supervisor. Do you remember? And this function return a time just to say you have to call me in at least, you have to call me again in at least sleep time millisecond, for example. So it should be 400 millisecond if you are performing a LoRaWAN transmission, for example, but it should be 2 hours if I have nothing to do. And so it's more or less call the run engine and go to sleep. Go to sleep for the duration returned by this function. So an application is just to be able to run the LoRa Basic Modem, you have just to call these two lines. So, and you see it's really easy also to implement in RTOS because you have just to periodically, so you put a task just to periodically call the modem run engine, and that's all. So, and after, everything is doing on what we call get events. So you will receive from the LoRa Basic Modem plenty of different events. So in our cases, the first one is modem is just reset. So just after reset, you have to probably configure something. So such as in the basic previous example, set the key, so DVE, joinery, and network key. But and in this net example, we would like just to, okay, so what you see, just after the join, it transmits a device management frame. Maybe you should want to avoid it because you don't want to use device management, or you don't want to pay for an extra transmission you don't want. So you can say, okay, I don't want to transmit this DM message, so you just put this DM message interval at 0. So, but what you have to see, just everything you have to do when you use the LoRa Basic Modem, it's called a API function which is in the SMTC modem API.h. So this is the API of the LoRa Basic Modem. So you have plenty of functions. I hope very documented. So it should be set the info field. Okay, for device management, I can take another one. Probably you have join, you have send, you have transmit, and so on. Okay, but everything is just in one file. So jump again to the main. So if you want to do not transmit the first DM message, you have to put the interval at 0, and that's all for the join. So after you perform the join, so when the join is finished, you will receive a join event. But what does it mean? It means if the join is succeed, for sure we will receive just after a join event. But if the join is not succeeded because there is no network available, or because it's not the right, it's still not the right frequency plan, you will receive also an event to say not join. But the LoRa Basic Modem by itself will continue to perform join. That means, and with the duty cycle of the join defined by the LoRa Alliance. That means at the beginning we just perform join every, I don't remember, the duty cycle of 1%, and after 6 years or 8 years, 8 hours, I don't remember, perform with 1,000 data rate, etc. Just to avoid to waste your battery for nothing. So, but everything is already implemented also in the LoRa Basic Modem. That means just put one line join and just wait for join, and let us manage everything. So don't be afraid to waste your power by too many join or so on. Just wait for a joint event. Okay, so after when we receive the join, in this first case we will just start an alarm to say, I want to receive a notification every 2 seconds in this case, or one notification in 2 seconds. So as soon as the alarm expires, you will receive an alarm event. And on this alarm event, we just collect the temperature, so this is also available, and request uplink. So we will transmit an uplink on port 106 on this alarm, and put a new alarm in 10 seconds. And just like this, we will periodically transmit an uplink every 10 seconds, and that's all. So this is what, well, this is more or less all the thing for just to cover the first point. Second point is just, I want to have a downlink, I have to receive a downlink, and on this downlink perform something. So just, we have also an event which mentioned you have received a downlink. On this event, we execute this code. That means this code is just, okay, clear the alarm. So that means remove the alarm because I don't want now to transmit periodically the temperature, but I want to start the clock 6 services. So that means now I want to wait to receive from the network the clock. So, and that's all. And if you receive, we will receive for sure an event. If you do not receive by itself, the LoRa Basic Modem will perform some trial periodically without to waste again your battery, just to acquire the time. So let's continue. When you receive the time now, so okay, when you receive the time, we print the time, just the network time, and also we will mimic, we fake a temperature collection, and we will transmit it with what we call a large file upload services. So the large file upload is just to transmit a large packet with redundancy, so you can lose a part of the packet, it will be, we have redundancy, it should be reconstructed at the end in the cloud services, by the cloud services. So I think it's more or less the full thing for this example. So, but we can just share with you the different other events. So we have a timeout ADR. Okay, it's more specific. We have a link ADR event when you receive from the network link ADR response. We have a link check. Almanac, it's for geolocalization. We have also event dedicated for the class B. That means ping slot info or class B statute to say, okay, I'm able to catch a beacon. I'm ready for class B. So maybe let's try this example in live. So I just enable the 1, 2, 4, 3, 4, 5, 6. Okay. Okay, I will remove the trace, the LoRaWAN trace, not the application trace, because it's too big. And compile and go. Okay, it's loading. Okay, in this example also, it's not the same keys, so it's not the same devices. So let's go. Okay. So, what we see? So, we have still join. So we have received an event join. And we periodically transmit every 10 seconds. And now we are waiting for a downlink to jump to a new stage to say stop the periodic transmission and try to get the network clock sync. But maybe just before to transmit this downlink, go to the LoRa cloud. For this is the LoRa cloud portal. Okay. So we can see my two devices, the first three and this one. And on this one, we can, for example, see just some information due to the fact we have not transmit the first device management, such as, okay, just the temperature and maybe the noise signal between the device and the gateway, but the device and the gateway is just here, so the SNR is very good. But, okay, if I want, for example, to know what is the ADR mode, what is the chip array of my device and so on, we have just to go like this, send a request to the device, select the type of request, should be get info, and for example, select what is your RDR mode, what is your importing interval, what is your WI, let's say, and so it's enough. Just send the request. So the request, in fact, is a downlink to the device. The device, but catch this downlink and answer it. But you don't see it at the application level. It's just inside the LoRa Basic Modem. It's the services embedded in the LoRa Basic Modem, but you do not receive any event to say you receive something. It's just managed by the device itself. So probably you have time to receive and to transmit the answer. So now, if you are looking again, okay, so the field is updated. The ADR mode is custom because we have just Semtech, it's not a network. I don't remember which field. The reporting interval is 13 seconds because we have changed it, and so on. So this is the reporting interval, not the delay between transmission of the packet, the reporting interval of the DM message itself. And you can report it, you can change it, you can modify it, you have the number of resets, and you can also, for example, make some action on your devices, such as, for example, reset or rejoin. And rejoin can help you sometimes. And of course, we have a full, this is a UI interface, but of course, there is a full API just to manage all your fleet like this. So now, continue. So messaging, transmit the downlink. Okay, I don't know if you have seen, but the downlink is required on port F2 and just one payload of 1 byte. Let's put, because the temperature, I think it's too high, so I will reduce the temperature by 15 and schedule the downlink. So you should receive the downlink. Okay, wait, transmission. You should. Oh, maybe I don't. Did I use a good one? Okay, should be okay. Okay. So you receive the downlink. You see it? So now we are stopping the periodic transmission, and we are waiting for the clock coming from the network. So no, you don't do this. I make a mistake on the port. It's not on port 1, it's on port 2. So there is a check in the code. So we start port 2. Okay, receive, and now stop the timer and wait for the GPS time update. Okay, so we still receiving the time. So now you can see the time, so the date of today, coming from the network itself, just by and we are mimic a large file upload. We are still to transmit every time with upload. But if I want to interleave a message just pressing the button between the file upload, I can do this. That's mean, and thanks to the supervisor to do this, I don't need to wait the end of the large file upload to be able to transmit another thing, because everything is interleaved due to with the supervisor. So if you see so you have large file upload performed on the F port 199, but you have also the transmission, the periodic transmission of the temperature on this port, and you have also on the port 102 the transmission of the temperature, just pressing the button. Not sure where was it, but it's there. Okay, so on port 1.02 it's the push button, here is the periodic uplink, and here it is a large file upload. So everything is interleaved. And you can see on the LoRa cloud now, probably, manage device. okay, you can see that you receive a large file upload. At this time, this is not the time of the US time, it's the European time, let's say. So that's more or less all for this example. Just to think, I don't know if, I'm not sure at the time. If I would like to change the radio, just to perform the same thing, but not on LR1110, but on 12, on a SX 1216, we have just to modify one thing in the compilation. Maybe I have the time. So just replace here the full LR1110 by full SX1260S, and it works exactly the same. So you can try one radio, another radio with exactly the same code, just by compilation. So maybe a last thing, if I want to use, because in the LR1110 we have a crypto engine, so we are able to derive the key inside the LR1110 itself and to use the joint server on Semtech. So like this, you solve also some issue to provision, to have the AVI and so on. So if I want to use it, I just keep exactly the same demonstration, the same code, just enable this part of code. This part of code is just, okay, just get the chip AVI of the device, put it inside the DVI, join AVI, and derive the key and get the pin. Like this, I will be able to get the pin. I can provision the device on the joint server on Semtech and perform the same thing. So but I have to say, So I have to say I want to use not the crypto element, but the hardware crypto element. So just by compilation, so keep exactly the same thing. Just say crypto equal to use the crypto of the LR1110. Okay, and compile, loaded. I will switch from the network now, because the device in this case is no more connected to the TTN device, it is connected to the Helium device. So I have also, so this device is here, or it should be here. So already provisioned on the Helium network. And now we'll launch the join procedure. No, I fell, because I know why, but because due to the fact that I changed crypto, it built a new bin, so it's not exactly the same name of the bin. LR1110 hardware crypto. Sorry. Restart. Let's start. Okay, so the chip area is the pin number. Start to join. On the Helium network, the first channel is not used, it is the second one. So the first channel, the first trial of the join is failed for sure, because it's not the right frequency plan. We'll wait for a moment, just try on the second one, and it should work on the second one. So just wait. Let's check what's happened. Okay, so there is delay between two joins. Okay, second one. Fail again. Okay. Checking the. Okay. Maybe. Let's make one trial and that's all. But normally it's work. But, okay, so we are just waiting, but. Just the first, for sure it's failed. The second one. Last trial, please. Okay, but maybe you can wait. But so I hope I succeed or I managed to show you. It's always difficult in like this, but to show you it's really not too difficult to implement something on top of LoRa Basic Modem. But what I want also to share it's like this, not only it's implemented very easily, I think, but there are plenty of security just behind. No, it fell again. So maybe stop it for this demo. Yeah, please. So just to explain, he receives the join, he transmits the accept, but why I do not succeed? Because, in fact, just a few words on this. The Helium network server is embedded also in the Semtech side, and sometimes it takes more than 5 seconds between the time to transmit, to push the Helium to the network, due to the fact that because there are plenty of firewall and so on inside Semtech. It's not a Semtech machine, it's a AWS machine, but there are plenty of checks, and sometimes it's too slow to be able to receive the downlink at the right time. Sometimes it works, sometimes it doesn't. But it's not an issue of the device or the Helium network, it's just an issue due to the implementation of the network server of Helium at Semtech. Or the loading of the machine, let's say. So please, can you switch back to the presentation? Thanks. So that's all for the live demo. No, maybe. Okay, so just have a quick look of what is the different services embedded inside the LoRa Basic Modem. So you can find everything on the developer portal, or it's strange. It's not exactly the good slide, but okay. So there is a mix between two slides. I don't know why, but okay. So if you are looking on the, so it's difficult like this, but what we deliver, it's what we see just before. It's a SW-LOO0, but we are also deliver at Semtech what we call the SDK. So the SDK, and I don't remember exactly the name, probably it's SDK 001 also, is providing you plenty of examples using LoRa Basic Modem. So in the LoRa Basic Modem, you just have one example just to try, and but if you want to have plenty of examples to demonstrate all the unitary thing of LoRa Basic Modem, please use a SDK just to have to perform trial. So, which kind of example you can find? Example, you perform large file upload, you perform LoRaWAN stack, very basic LoRaWAN stack, but also class B multicast, and class C and stream. So stream, it's a kind also of periodic transmission with redundancy, time synchronization, and so on. And we have also plenty of examples to demonstrate the geolocalization performance, such as Wi-Fi, GNSS, how to use it, how to optimize it. So there is plenty of examples embedded inside this SDK. This code is also available in GitHub. So next. Okay. So it's very beautiful like this, but it is running on the EVK board, let's say. For sure it will be not your board. And you will probably have a different MCU, different hardware, different paths. So you have to adapt or to plug or to port the LoRa Basics Modem on your MCU. So, and I think we tried to do this easier as possible. So I want just to show you also in my laptop what you have just to modify to be able to run this same demo, but on your own platform with another MCU, with another thing. So can you switch again, please? So in fact, everything is here. So you have to implement what we call SMTC modem al.h. So what we have here, maybe just remove the terminal. So we have few functions very dedicated to the MCU to implement. It's a very basic one. It should be a reset. It should be a reload watchdog, and so on. So just see how. Just see and to list them from the beginning. So just reset MCU. In this case, it just calls the IL of your MCU API. It just perform a reset of that thing. Reload watchdog, get time in second, and get time in second, it just please provide me your RTC time. Same time for compensate, it just use for clock sync, but you can provide exactly the same thing that get RTC time, except if you have a hardware compensation of your device. If you perform 32K compensation with temperature and so on, you have probably an offset to add. Just put here. Same thing. Provide me the get time in milliseconds, in 100 microseconds. Okay, it's more or less redundancy probably. Just give me the timestamp when you receive an interrupt from the radio. Please timestamp this interrupt. Start a timer because, as you see in the radio planner, we need a low power timer to execute the different things. So just provide an API, provide something to be able to start a low power timer. To stop the low power timer, disable IRQ. Okay, context store and context restore. You know, for LoRaWAN implementation, we have to store some parameters, such as at least the dev nodes and the join nodes. So, and I think it's more or less the only thing we store for the LoRaWAN. In your cases, just the dev node or the dev nodes and the join nodes, just to avoid replay attack, in fact. We also store number of resets, but it's just for device management. So just provide a way to be able to store or restore something in the memory. Just crash log is just something. Okay, assert is just because you just implement a security assert. Random, give me a random number, random range. And more or less, if you want to perform something, if you have a TCXO, probably you want to do something before to start the TCXO with the radio, or maybe you want to do something after the TCXO. So you can just plug your code here if you want to perform something before the TCXO or after. And I think, except, okay, get temperature, get level, and print, and that's all. So just fill this function. It's just enough to be able to switch from one MCU to another one. So I think it's, and you have an example. You have also example in the SDK itself. So I think just follow this example. It's not too difficult, in fact, or I hope it's not too difficult, to be able to switch from one MCU to another one. So I make a little bit shortcut, let's say, because you still have something to add. It's two things. Your pinout, for sure, on which pin you have attached your SPI, your ART, and so on. So just in this file, put the pin number of your MCU where you attach it. And you have also to fill this file. This is just a way to access to the radio. So just how you perform a write SPI and a read SPI, more or less. It's more or less this thing. So just fill this free file, and it's enough to switch from one board to another board. So I hope it will be a big step compared to the previous stack, you know. So that's all. Can you please switch? Okay, so I hope I succeed to convince you that it's really easier compared to what you have done before. I hope so. So the next slide. Okay, so now you are, I hope you succeed a POC, but now you have, using LoRa Basics Modem, but now you have to go in mass production. And it will be every time a challenge to transform a POC to a real product without any difficulty. So we are trying to put a lot of things inside the LoRa Basics Modem just to solve you or to help you to succeed in this step. So I just maybe mention some of them is really different things. For sure, it's certified. Okay, it's the minimum, but it is. So it's certified with an independent test out for all the regions. FCC, HC, and so on is also perform a test model are also embedded to ease your life to perform and to pass this test. Okay, as I mentioned before, the 32K crystal accuracy is always a nightmare. And more again when you are in class B. But so we have implemented plenty of things to remove this complexity, to remove this constraint of the crystal accuracy. It should be, as I said before, adaptive timing for X window. Same thing for class B. We have a kind of digital firmware digital PLA just to track the beacon. So to be able, even if you have a bad crystal accuracy, we are able to track the beacon. Same thing for, okay, so if you have now, another thing is you have a delay, a board delay, and it's always also difficult to measure and to put inside the code itself just to be able to open the window exactly at the right time. So we also have algorithm for estimate this delay and to compensate it. Okay, the battery life is also something difficult to, when you start to implement your device, you would like to know exactly the consumption for 10 years, for exactly. So you need something to really estimate the battery life. So internally, we have implemented the gate charge, so it's just something that provides you the gate charge. But also with the distribution of data rate and so on, you can exactly imagine the consumption we will use if you are not in a network control devices. Reliability, as I said, it's really, I think, the most important thing inside the LoRa Basics Modem. We have plenty of security, plenty of things, and we have also a dedicated team, maybe 4 or more than 4 guys, we perform tests every night, continuous. It should be end-to-end tests. It should be unitary tests, etc. So we have a very, very large non-regression test suite running every day, every night on this stack. Okay, so this point is just to give you an example. When you go in mass production, for sure, you will also ask to the manufacturer to load your firmware. And when you load your firmware, you want to check if everything is done correctly. So we already embedded a small check to provide an estimation of if everything is okay or not, but it's very short time because what you pay, it's the time of the test. So we already have implemented also this kind of thing. Okay, device management and closed services should be useful for if you forget the reset, if you forget the region, or it should be useful if you forget something on your device. And the last point, but I think it's very important, it supports natively the photon. So the last implementation of the photon. Oh, yes, but I think you have seen during the presentation. Just very often we ask me how you debug all these things, and because it's real time, because it's okay. So most of the time I use what you have seen just before. It's the power consumption, the OTTI. This is just a very useful object. We monitor the power consumption in real time. So like this, I can see this is the transmission, this is the reception. I can measure the transmission, the time between the transmission and the reception. I can estimate the power if we are not in right sleep mode, if I forgot to switch on GPIO and so on. And as you see, it's always linked to the printf. So I can just take or research a specific text and just know the consumption at this right time. So I can see plenty of things with this. And it's really a very useful tool and for debugging. So thanks a lot for your attention. And if you have any question, please. Yep.
So I'm working with LoRa for small package logistics. And what was interesting on your presentation was that looks like you have region, one sensor can operate in multiple regions.
Yeah.
Is that is built in at the base layer, I assume? And I'm not going to develop my own sensor. I want to buy it off the shelf. Would you anticipate the various LoRa sensor vendors having this new stack available?
Mm-hmm. And your question is how to switch from a region?
Well, so I ship boxes from Bay Area to Belgium to Australia, stuff like that, and it's all different regions. So currently we just stick a US one for the US leg and a European one for the European leg. So it'd be really nice if we could put one GPS sensor in the box and it realizes, oh, I'm no longer in Memphis, I'm down in Paris. So
Yes.
I switch.
Exactly. So, and we have a demo we perform this. We just use an accelerometer. When you plug the device like this, it starts in Europe. Like this, it starts in US. So, and it's really feasible because, as you see, you can compile your code with an embedded other region, and just on the event reset, catch your GPS, find the region, set the region. That's all.
Okay, and then so then that's up to the developer then to access that and use it. And then when will this is this brand new, or when will this be available to? When do you think it will actually hit the market so I can buy a sensor that uses it?
And you see a sensor we already embedded the LoRa Basics Modem? That's what you ask?
If I could buy one of these tomorrow, can I? Or how can we build this into our business? I guess is what I'm asking. How soon will this be available? Or is it available today?
It's already, for sure, it's already available on the source code is already available. We have some of device maker is already using it and already implement it and use it. And but I'm here just to populate this. Yeah. But yes, it's already available since about 6 months, I believe. Yeah. It's the third drop in the GitHub. Other question? Yes. And I think it will be more and more popular again as soon as we have, because as you see, the relay will be also implemented on top of this. So I think it will be probably the first implementation of the relay itself on a stack. So I think it will be more popular again with this implementation. I hope.
How much of the standard C library do you need implemented on your MCU? Are you using malloc?
No malloc. No, it's very, very light one. So there is no malloc for sure. It's really very basic and very usual for embedded devices. So
that you know the RAM footprint for this one?
yes, exactly. Yeah. So, and you can provide, I don't screen this value, but you can more or less provide it. It depends, of course, of all the services you embedded or not. If you choose, for example, a large file upload with 8K of RAM, for sure it's 8K of RAM extra cost. But if you choose a normal configuration, let's say, it's more or less 64 KB for flash, so for the program, and less than 10 KB for RAM, for full region.
And do you have AES in the software for the encryption?
Yes. It should be chosen. The encryption should be done by software, or should be done, as you see at the end. Yes. So you can choose if it is free choice, in fact. Software inside the LR1110 kind of crypto engine, or with on an external MC crypto element. So you can just configure it. Other question? I know I was long. Yeah.
Am I working? All right. Do you have to tie into any interrupt handlers? You basically had callbacks in there. You just fill in those callbacks. Can they be done at interrupt mode? Do you have to tie into? Does your library need callbacks directly from interrupts? Could they be done a little bit lower? For like the timer callback?
Yes.
The
timer,
IRQ.
The IRQ, yes. What you say? What's your question?
Do you need integration into the interrupts of the controller, or?
No.
Okay.
No, on top of it. In fact, on the interrupt, we just put a flag. That's all. Yeah. With the time of the, just timestamp the interrupt, in fact.
Thank you, Fabien.
Thanks.